Greetings, we are from group number 6, and today we are going to talk about the topic servo motor. The first speaker is me, Jiraphatr, talking about the introduction, concept, and principle. So let's get started with introduction. What is a servo motor? A servo motor is a rotary actuator that allows us to control angular position, acceleration, and velocity with high efficiency and great precision that a regular motor cannot do. The concept of a servo motor is to use a regular motor, pair it with a sensor for the position feedback. The controller is the most complicated part of the servo motor because it is designed for a specific purpose. The output shaft of this motor can be moved to a particular angle, position, and velocity that a regular motor cannot. The motor is controlled with an analog and digital electrical signal, which determines the amount of movement, which represents the final command position for the shaft. Encoder serves as a sensor, providing speed and position feedback, which is built right inside the motor, which fits in a gear system. The working principle of servo motor can be divided into two types, DC and AC motor. For DC, the desired speed of the motor is based on the voltage applied, and the length of the voltage pulse control how fast the motor will rotate. Then, the feedback signal sensors using a potentiometer produce a voltage related to the angle of the motor shaft through the gear mechanism. Then, both output values will be compared for the error and calibrate until there is no error anymore. For AC synchronous, there is a stator and rotor. Inside a stator, there is an armature coil surrounded and connected with a lead wire to provide current for the motor. The rotor consists of a permanent magnet that uses electromagnetic rotate between the two parts. When the stator field is excited with voltage, it will rotate the magnetic field of the stator at the same speed, which causes the motor to move. On the other hand, AC asynchronous stator is fed with an AC supply, produced by alternating flux to get synchronous speed. The speed by the magnetic field causes an electromagnetic force according to Faraday's law. Now, this rotor produces a flux field around itself and make the rotor rotate in the same direction to make the motor move.
For the type of servo motor, me, Worraphong, is going to explain. First, DC servo motor is the motor that is used as a DC servo motor, which has a separate DC source in the field of winding and armature winding. The control can be achieved either by controlling the armature current or field current. The advantage of DC motor is it can provide a very accurate and also fast response to start or stop command signal because of the low armature inductive reactance. Next, AC servo motor is the motor that includes an encoder and used with controller for giving closed loop control and feedback. These servo motors have higher design of tolerance or better bearing, so it can provide higher accuracy and also use higher voltage for greater torque. Next, positional rotation servo motor is the most common type of servo motor. The shaft rotates about 180 degrees. It includes physical stop located in the gear mechanism to stop turning outside this limit to guard the rotation sensor. Next, linear servo motor is similar to the positional rotation servo motor, but it has hexta gear to alter from circular to back and forth. These servo motors are not simple to find, but sometimes you can find them at hobby store. where they are used as a actuator in higher model airplane.
For continuous rotation servo motor, it can go in any direction indefinitely. The control signal, rather than set the static position of the servo, is understood as the speed and direction of rotation. The length of potential command source the servo to rotate clockwise or anti-clockwise, as preferred. As changing speed depends on the command signal. And Burid, I will talk about how to select servo motor. To choose a servo motor that is suitable for the application, there are three main things to consider. First, calculate the motion system optimal inertial ratio. Inertial ratio is the ratio of the load inertia divided by the motor rotor. Inertia is defined as an object resistant to change in velocity and in servo driven system. Choose to suit the type of work you want to use. Second, speed of servo motor. The operating speed of a servo motor is defined as the time required for the shaft to reach a specified position. Another important factor when choosing a motor size is speed. We need to know how fast and how far the load is moving. If we are using the motor for repetitive motion tasks, it helps to determine the required motor speed throughout the cycle. Third, determine how much torque the motion application needs. Torque is how much muscle it takes to rotate a mechanism and come from three different sources, accelerating the mechanism inertia. It is necessary to select enough for use to prevent system crash and prolong the service life of the servo.
Next, my part is how to apply and how to code. So me, Pongsiri Siritammaphand, to speak about how to apply. Servo motor are great device that can turn to specified position. Usually they have a servo arms and can turn 180 degrees. Using the Arduino, we can tell a servo to go to specified position and it will go there. As simple as that, servo motor were first used in the remote control world. Usually the controls are steering of RC cars and flaps on the RC planes. Real time default the use in the robotics automation and of course the Arduino world. Here we see how the connects a servo motor and then how to turn in the frame position. The first motor I ever connect in the Arduino 7 years ago and was the servo motor. You will need the following things. First, an Arduino board connects to computer via USB. Second, a servo motor. Three is a jumper wire. Step 1, how to connect them. A servo motor has everything built in a motor feedback circuit and most importantly, a motor driver. It just needs one power line and one ground and one control pin. Step 2 is code. The following codes will turn a servo motor to 0 degree, wait 1 second, and then turn to 90, wait 1 more second, then turn to 180, and then go back if the servo motor connects in the other individual pins. Simply change the volume, the servo pin and volume and digital pins that has been used. Step 3, how it works. Servo are clever device using just one input pin and you receive the position from the Arduino and they go there internally. They have a motor driver and a feedback circuit that make sure that the servo arm reach and decide position, but the kind of signal they receive on the input pin.
Me, Chanon, I'm gonna talk about application of a servo motor in robotics. First, servo motor in robotics. One of the most popular servo motor application is in robotics, considering a simple pick press robot. A pick and press robot is a robotic machine that picks an object from the one position and presses the object at a different position. Now, in order to pick an object from position A and press it in position B, the motor, which use the actuator joints are servo motors. This is because we have a plan of angular moment of each and every joint to complete this task of pick and place. Replication of servo motor in robotics can be explained on a small scale in electronic projects. The base Arduino starter kit will include a small servo motor in experimentation to servo motor application in camera autofocus. Today, modern digital cameras are very advanced. One of advanced feature is ability to autofocus on the object on the capture. When the image of the object is created within digital signal processor of the camera, it checks to sharpness. Basically, if the local length which is measured from the camera lens is not proper, the image appears is blurred. The corrective action, the position of lens physically so that the sharpness image is captured is done using a highly precise servo motor field within the camera. 3. Servo motor in robotic vehicles. A robotic vehicles today is used a highly complementary as well as industrial applications use servo motor for wheels. Here the angular movement is not of importance since the servo use it a continuous rotation servo. The ability of servo to generate enough torque so as to quickly move the vehicle from the halt and quickly stop it as well. What is important also the velocity with which the vehicle should move can be controlled. 4. Servo motor in solar tracking system. Solar power generation are used gaining importance as people move toward clean and renewable energy regimes. Earlier, solar panels that were installed were static and remained in one position for the entire duration of the day. General science that the sun is not always flexing in one direction, and that it is position relative in solar panel which change. This implies that we are not fully untilting the power the sun is attracts maximum energy, but if we attract servo motors to the solar panel in such a way that we are able to physically control its angle of movement so that is closely follow the sun, and the overall efficiency of system vastly increases.
Here are several of the more common servo motor applications in factory use, and me, Netinun Marneerung. Servo motors are also found in the spinning element of conveyor systems that are popular in bottling, packaging, tactile, and printing. Let's consider an example of the bottle filling process. In this process, the bottle needs to be filled with the liquid and moved to the next stage, which is mainly the packaging stage. So, in order to achieve this, conveyor belts are used with servo motor so that the bottle moves precisely to the desired location and stop, so the liquid can be poured into it and then it is guided to the next stage. Servo motor in tactile industrial. Servo motor control industrial spinning and weaving machine, loom and knitting machine that product tactile such as carpeting and fabric, as well as wearable items such as sock, cap, glove, and mitten. Next, servo motor in metal cutting and metal forming machine. Servo motor provide precise motion control for milling machines, lathe, grinding, centering, punching, pressing, and bending. In metal fabrication, for such items, as stylist to automotive wheels. The last example, servo motor in the printing industrial. Servo motor stop and start the print head precisely on the page, as well as move paper along the print multiple row of text or graphic in exact lines. Whether it is newspaper, a magazine, or an annual report, the use of servo motor or integrated drive motor in the printing industry offer a wide range of performance tuning, such as first, better precision thanks for the programming. They can be programmed to intelligently adjust print parameter during a print run, correcting for error and reducing wastage. Second, versatile performance. Servo motor allow for the equipment to print on demanding substance. Third, a flexible approach to printing with fast turnover item. And fourth, great level of automation, reducing operational requirements. And that is the end of our presentation. Thank you for listening.